What is the effect of supersonic aircraft to ozone layer? Have you ever wondered how the technology of supersonic aircraft impacts our atmosphere? Let's break down the effects these high-flying machines have on the ozone layer. Supersonic aircraft operate at much higher altitudes than regular passenger planes, often cruising in the lower stratosphere. This is the very region where the ozone layer resides. The ozone layer plays a vital role in absorbing most of the sun's ultraviolet radiation, which protects life on Earth from harmful effects like skin cancer and cataracts. When supersonic aircraft are in operation, they releases pollutants directly into the stratosphere. One of the most concerning pollutants is nitrogen oxides, often referred to as NOx. These emissions from supersonic engines can significantly reduce ozone concentrations. NOx acts as a catalyst in chemical reactions that break down ozone molecules. Consequently, this leads to a thinning of the ozone layer, allowing more ultraviolet radiation to reach the Earth's surface. The impact of supersonic aircraft on the ozone layer is influenced by several factors. The altitude at which these aircraft fly is particularly important. The higher the flight, the greater the potential for ozone depletion. This is because more NOx is released directly into the ozone-rich regions of the stratosphere. Additionally, the number of supersonic flights matters. If supersonic aviation becomes widespread, with thousands of aircraft flying regularly at these altitudes, the effect on the ozone layer could be substantial. Some scientific models suggest that a large fleet of supersonic aircraft could reduce the global ozone column by several percent, and in extreme scenarios, by as much as 10%. Other factors can also influence the extent of ozone depletion. For instance, the presence of sulfate aerosols in the stratosphere can convert some NOx into less harmful nitric acid. This conversion slightly reduces the overall impact on ozone, but it does not eliminate the risk entirely. From a political standpoint, the issue of supersonic aircraft and ozone depletion presents a balancing act. On one hand, supersonic travel offers the potential for faster international connections and economic benefits. On the other hand, the environmental risks are clear and well documented. Politicians must weigh the trade-offs between technological progress and environmental protection. They may face pressure from industry groups advocating for the advancement of supersonic aviation, as well as from environmental organizations and the public, who are concerned about the health and environmental consequences of ozone depletion. Policymakers have practical applications to consider, such as setting regulations on the altitude and number of supersonic flights. Investing in cleaner engine technologies and supporting research into the long-term effects of high-altitude aviation on the atmosphere are also critical steps. Decision-making in this area requires a clear understanding of both the scientific evidence and the potential economic and social impacts. In summary, supersonic aircraft can harm the ozone layer by releasing nitrogen oxides into the stratosphere. This leads to ozone depletion and increased ultraviolet radiation at the surface. Politicians must carefully consider the benefits of supersonic travel against these environmental risks when making policy decisions. The context of planetary atmosphere chemistry is directly relevant, as it helps explain why the altitude and type of emissions from supersonic aircraft are so important for the health of the ozone layer.